I warned you, Jenkins, I think I've got a replacement for you. So what can you do for me? Oh, anything else?
I can clean the lathe.
Blimey. Anything else?
I can sweep the floor.
Excellent. Right, get your coat, Jenkins, you're out of here.
At last my plan for world domination begins.
What was that?
Hello! And welcome to Tweed's Garage.
Right, come on, out you go.
No, put it down.
And good riddance. Hello and welcome to Tweed's Garage, where in this episode we're continuing work with the Bantam B175 engine strip down and repair. So got it all apart the other week, found lots of disasters in there, so now is the time to sort of try and work through stuff and get it back up together. So parts have been ordered and a little list is being made of parts that are missing. Some of you eagle-eyed viewers noticed that the crankshaft didn't have any shims on it, so it wasn't shimmed up properly, so we need to get some shims. That's one of the things, and a few other bits and bobs. But one of the things we can't get is the gearbox, sorry, the clutch bush. It's a two-part bush. It's got a steel inner and a phosphor bronze outer, but nobody appears to have any stock of these at the moment, so I decided to give it a crack and try and make one. So the first thing I did was have a route around to find a piece of phosphor bronze that would be big enough for the job. Had a bit that had a sort of hole bored through it that would do the job, a little bit big, but you know, I've had it for years and hasn't been used, so we might as well put it to good use. And then a piece of steel bar for the inner. So the first thing to work on was the steel bar. So over to the lathe, and we pop that in the lathe, and first thing we do is centre drill it. And then we run through a slightly bigger drill all the way through, a little bit further than the depth of the bush that we want to make. Followed by the biggest drill I could put through before boring it, so it's a 15mm drill that I put through it. With that done, it was a case of boring it out to dimensions with a small boring bar, taking it gently and working my way through it, and kept measuring and test fitting until I got the size that I needed. Now, it's not a revolving fit, it's a sliding fit, and then when the clutch assembly is bolted together, that is actually sandwiched between the inner clutch assembly and the bearing at the back, so it doesn't actually revolve. The clutch basket revolves on the bush on the outside of it. With that bored out to the correct diameter, I then turned down the outside face to a sliding fit to go inside the bush. So I measured as well as I could the outer diameter of the steel two-part bush, and then worked to that as my finished diameter. With that turned down to size, with a file, run a nice little chamfer on both edges, one edge on the outside edge and then on the inside edge as I parted sort of halfway through it, and then parted that off. and then just popping out on the shaft, you can see that goes on quite nicely. So with that done, I moved on to the phosphor bronze bush to push over the steel inner. So I chucked up the piece of phosphor bronze, and then turned down the outside diameter. I left it a bit generous because it was going to be a push fit. I didn't want it to crack. I didn't want to make it too thin and have it crack when I pushed the steel liner inside it. So I left it oversized. And then with that done, bored out the inside of the bush for a push fit on the steel bush. And then with that done, I spun round the whole piece of phosphor bronze, popped it back in the lathe and just faced the back of it to make a nice flat surface for me to press this assembly over onto the steel bush. So with that done, popped it out of the lathe, took the steel bush, popped next door to the press and pressed the steel liner into the bronze bush. And that went in really nicely, and I just left a little gap, a little bit of clearance between the end of the bronze and the end of the steel, like the original one. Yeah, because I think the steel liner is there so that when you tighten it up, it doesn't crush the phosphor bronze. So you leave a little bit of clearance at each end, so it's just resting on the pressure's resting on the steel rather than the phosphor bronze. So that pressed in nicely. So with that done, I popped it back into the 3-jaw chuck, and then just to make sure it was running true, run a clock on it and just tapped it till it ran true and tightened it up, and then done the final turning on the outer face down to dimension. And then just check the fit with the clutch basket that it went over it, which it did. It went over quite nicely. So with it turned down to finished size, the only other feature that it has is an oiling scroll that runs around it, and the actual pitch of that is one thread per inch, but my lathe only goes up to 2 threads per inch as the biggest thread that it will cut. So I had to set the speeds down really low because everything happens really fast. The bigger the pitch on the thread, the faster that the carriage moves. So yeah, just slowed it right down. But unfortunately, because you guys were watching, I did cock it up and ended up with 2 scrolls because I panicked halfway through and disconnected the motor speeds, which lost my placing with the index on the lead screw. And it's not so simple on my lathe because it's got the Angest quick threading gearbox on it. It doesn't have the dial indicator on it, so you have to sort of, what I'd done was put a little pen mark on the bush, and I was using that as my start point for engaging the lead screw, which was going okay until I disconnected the speeds, and then I lost my place. So I ended up with 2 scrolls, and also I crashed it at the other end as well. So being happy with that, the last thing to do was to part it off to size. So again, I measured the width of the original phosphor bronze bush and started to part it off, and then gently fired a chamfer before the parting tool went all the way through, and then continued parting off until then it broke through the bronze, left that little bit of clearance between the end of the phosphor bronze and the steel, and it dropped off. Ready to be mounted on the bike. it will do for now. It fits nicely, and it just sort of proved whether you could actually make one or not, which you can, as you can see. Yeah, so I might have another crack at it and turn another one up, or I might completely forget about it and leave that one in there for now. So, 2-part bush, you can make them. Yeah, a little bit of patience, you can make them. So that was the first job. Then we moved on to the stuffing plates. If you haven't seen the previous video, these plates are mounted on the sides of the crankshaft to increase the crankcase pressures and sort of decrease the volume of air in the crankcase by blocking off the casting hollows on the flywheels. And what happened on this Bantam is one of them came loose at some time, caused a bit of death and destruction, and when the engine was rebuilt they didn't replace it, they left it off, so it only had one stuffing plate. And these, again, they're an item that you can't, they're difficult to find. There might be some kicking around somewhere, but I thought I'd have a go at making these. So here it is, here's the stuffing plate. It's a piece of sheet steel, with nice and round, with a hole for the crankshaft main shaft, and then another hole for the big end pin, and then 6 holes around the outer edge to secure it to the flywheel, or not secure it to the flywheel, as they have a habit of falling off. So I decided to make 2 of these. So I found some steel that I can make them with. It's a little bit thinner, about 0.2 of a millimetre thinner, but it doesn't make any difference really. The tricky thing is I had to work out how to machine them. Get my steel, blue it up with engineer's blue, and then start marking it out. So the first thing you do is mark out your outer diameter. That's easy to work out. Just measure the recess in the flywheels to give you your outside diameter. You want the steel plate to drop in. Then you measure your crankshaft spindle on its outer diameter to give you your next measurement, or measure the hole in the plate, and then the same again for this pin. And then you sort of have to sort of gauge carefully, you know, a set of vernier calipers, measure across there and there, and work out your pitch circle diameter. So you want to work out what the diameter is at the centre of all these holes. So you measure that, work that out roughly. If you're machining it like I am, and you can overlay this plate and use this as a guide as well. So you've done this measurement, you know the diameter of this hole, you know the diameter of this hole, this is in the centre, and then this one is easy to work out because it is just basically half the stroke of the engine. So the stroke of the engine is, hang on, so the stroke is 58 millimetres on the 175, so you're looking at 29 millimetres is your measurement that you need for the centre. I then use an angle grinder, cut the plates in half, so I've got 2 square plates, mark the centre, and then ran a centre line through the plate as well, so I could make sure that that was, when that was on the mill, it was running true, so that when I drilled all my holes, like the 2 crank, so when I drilled this hole, this hole, this hole and this hole, they're all on the same plane, and then you've got your centre hole marked on the plate. Put the 2 plates together, centre punch the centre hole on one of them, and then I took them over to the milling machine where I'd put a piece of board in the milling vise, and I was going to fix the plates to the board and then do all my machining through that, so it supports the plates, because working on thin sheet material is a nightmare. So first thing to do was drill a hole through the centre, then screw it down to secure the plates to the board, and then work my way round and drill 4 holes, 1 at each corner outside my markings. And then secured these with screws and took the screw out of the centre to do all 4 corners. So now I could machine that plate quite happily without having to touch the screws or move it until I'd finished all the operations. So with that done, using the digital readout, I moved the milling position back to 0, so I was back on my centre marking point, and then I ran a step drill through the sheet metal, because they're sort of the best drills to cut through sheet metal, and then went to sort of the biggest size I had on that. And then with that done, I then moved to my 29 millimeters along the x-axis and drilled my second hole, which is for your big end pin, and then just sort of drilled that to the size, just below the size that I actually needed. And then that's those 2 main holes done. But I decided to drill the 6 holes next, and then do the boring last. So with those 2 holes drilled, ready for boring, I moved on to drill the 6 holes around the outside edge. And I've done that with the holes in a circle program on my digital readout. So I sort of put in the details of the diameter of the circle that the holes were going to go on, the start position and the finish position, so it's a full 360 degrees, how many holes, and yeah, with that all set in, off you go. So you sort of move to the first position, centre drill it, and then drill it. And then with that done, then you press the advance button, go on to the next hole, and then the next hole, and the next hole, and the next hole, until you've completed the program and you end up with your 6 holes. I did overlay the old plate and ran through the program without drilling any holes, but with a centre in there, just to check that the holes were going to be sort of where my markings were, and you know, within the same region as the plate, which they were. So, and because you've got the 2 plates, you're drilling them both at the same time, job done. So then with the 6 holes drilled, moved on, put the boring head in the milling machine, and then move the mill back to 0, 0 position on the X and Y, bored out the centre hole to the diameter that I'd measured on the old plate. And then moved it 29 millimeters over the second hole, and then bored that to size. And as you can see, that went really nicely, and it sort of gives a nice finish. So with that done, all I've got to do is finish off the outside edge. So what I've done was got an angle grinder with a very thin cutting disc, cut them out as round as I could, which didn't take very long with it because they're thin sheet steel. So with that done, I turned up a little mandrel out of a piece of scrap aluminium that I had, just turned it to the diameter of the crankshaft, out a diameter, for a nice tight fit on the plates, and then a little bit thinner than the two plates together. Put the plates on, and then I had another sort of aluminium bush line around that was just the right size, and a nut and a bolt and washer, and then bolted the plates to the mandrel, and then very gently turned them down. It gripped okay, but you couldn't go too mad because they would spin occasionally. So yeah, you just had to make sure they're clamped really tight. Just take it easy, nice sharp tool, and just take them down and to the diameter that you need. And they turned out really well. I was really pleased with them. They look really nice, you know, sort of pucker job. But I'm very fortunate. I've, you know, got the machinery to do it. If you haven't and you wanted to make them, you could make these by hand, you know, with some accurate marking out, like I did at the beginning. Blew it up and then get all your measurements and scribe it out nicely so you got guidelines to go to. Yeah, you know, and those two holes are easy to work out their positions. You know, that's half the stroke from the centre, so that they're easy enough. And then these two holes are on the same line. So as long as you're drawing a straight line through the middle of your circle, that will be your baseline. And then you can scribe 6 positions and work out where these holes are going to be, or you can work it out on the back. If you've got a Zeus book, they have all the coordinates at the back there. So to get your dimensions, there's your 6 holes. So to get your dimensions, it says there, multiply values shown by diameter of pitch of circle. So just multiply by the pitch of this circle that you've marked. And by the miracle of maths, that will give you all your positions to scribe on here. Focus. Scribe on here. So yeah, you could do it on a pillar drill all your holes, drill these. You could file them quite happily. They're not critical. They're meant to seal up this void, to eradicate this void. Like that. I'll put it back to front. But as you can see, the muck behind there, they're not gas tight, so it doesn't 100% work. So what I'm going to do is when I fix my plates, is run a bead of engine sealant around the holes and screw them down. But to stop them coming off again, I'm going to use countersunk screws, screw the screws in, and then just TIG weld the screws to the plate to stop them coming undone. So that's that job done. So with those bits done, it was sort of just to finish stripping down the crankcases. So pushed out the last of the remaining bearings, used the press again, come in handy, and then it's just a case of I have to start degreasing them, ready for reassembly. So there you go, bit more progress on the Bantam. A little heavy on the engineering. Hope it wasn't too daunting for some of you, but I know some people do enjoy it. So yeah, and it was really enjoyable. I really enjoyed making those plates, and when they come out at the end, I was really, really pleased with myself, if I say so myself. But you know, you've got to pat yourself on the back occasionally, because Mrs. Tweed doesn't. She's always telling me off. So until next time, see you then. If you enjoyed the video, give us a little like, and if you want to see more, subscribe and hit the bell icon and you'll be notified. And like I said on previous videos, if this is the first one you've seen, I'll put the little playlist of all the other Bantam videos down below so you can go and find those as well. Okay, all right. What's that, Jenkins? Yeah, you can put your coat back. You're back on the cards. All right, see you next time. Cheerio. Right, go and clean that lathe down. So I had a route. I think you're fired, Jenkins. Get your care. 5 Bantam engine.
Yo voy a cantar esta canción, yo voy a cantar esta canción para mi gente con una pasión.
So
Con una pasión tan fuerte. Ay, 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 ay. Ahora sigo cantando y sigo gozando.